Hey, what's going on, everyone? Welcome to my final video of Psychology 325. This week, I will talk about the topic that I was most looking forward to, which is the grand illusion of conscious perception. When I first learned this, I thought it was quite a doozy and an interesting discussion, so I hope you find it intriguing as well by the end of this video. The grand illusion of conscious perception is something that we touched on before. The illusion is that we're constantly seeing a clear, detailed, and complete picture of the world around us. And this is a very strong illusion. It doesn't matter if you know it's true. You can try your hardest to catch yourself, but you will always perceive a richly detailed, clear, and complete world around you in the end. But we know that this is false, this is fake. Inattentional blindness, change blindness, and change detection showed us that even the blatant details that are right in front of us can be effectively invisible without explicitly directing our attention in that direction. And the visual system itself imposes some substantial constraints on what we can possibly see in any one moment. But before I talk about these constraints, I'm going to go left field a bit to talk about the second law of thermodynamics. I don't know if you have taken physics in high school or in college, but the second law talks about the quality of energy. And there are multiple ways to explain this second law, but the simplest way I can explain this is that anytime you are transferring or transforming energy, some of it will get wasted, and you never end up with the same amount of energy that you once started. And to illustrate this point, I will use one of the classic American science action films, The Matrix. And as perfect as this film is in terms of action, storytelling, originality, character development, and choreography, Matrix violates the second law of thermodynamics. For example, if you have an energy, and if you want to put the energy up there in North Shore from the airport, there are several ways that you could do it. But if that energy from the airport to the North Shore transform in any way between here and there, you lose something. For example, if you have gasoline measured on how much energy is in it, you put it in the car and you run the car, you will find that the car does not run on 100% of the energy that you once put in it because it loses some of that energy to heat because the engine gets hot. But the temperature of the engine does not help you to go forward. It is lost energy that was once contained in a gallon of gas you once put in. And you always lose something if you go through steps. So with this logic, the best thing to do is don't go through steps. And the premise of the film The Matrix is that the future machines use humans as an energy source to drive the Matrix. Humans are harvested and kept alive because we actually radiate about 100 watts of energy, which is the energy source of the Matrix. And this was analogized to a copper top battery. And here's the problem. Keep in mind, these are humans. You have to feed humans to keep them alive. Whatever you're feeding them has an energy content. So think about the same logic with the car ride. The problem with this film is just use the original energy from the food to drive the matrix and bypass the middleman. You don't need humans because you're losing energy by putting human beings in the middle of all of this. Like so, each layer that the visual information from the eyes to all the way to the back of the brain, it loses something as the information is transformed and transduced along the visual pathways. The raw light energy or the raw electromagnetic energy goes through multiple layers of cells just within the retina, changing its property from the electromagnetic wave into the electrical chemical energy that our brain can understand. And the converted information goes through further checks within the different parts of the brain before it finally reaches the primary visual cortex to organize the low-level information. Thus, as it travels across its distance, the visual information gets degraded as it moves through the brain's visual organs, impacted by the laws of the thermodynamics. And we also know that our eyes are not the perfect cameras. The signals from the eyes to the brain are compressed by 100-fold, and within our retina, our visual acuity varies dramatically with a high detail and color only available in the center of the visual field. And there are also various visual disruptions related to movement and maintenance of the eyes. Every time we shift our gaze, which is several times a second, the visual world is necessarily blurred and smeared across the retina. And in fact, we actually expect this. Modern visual effects in films have to include what is called emotion blur in order for a computer-generated effects to be believable. Considerable time and effort goes into crafting these models and simulations, but for the final product, all this work has to get blurred when something is in motion, or else we won't perceive it as a real. And in addition to blurring, there are many periods where visual perception is simply turned off, and this happens during saccades, the rapid shifts of the eyes, and during blinks. And in both cases, we barely notice any disruption, but in reality, the visual input from our eyes is briefly shut off, not only by the eyelids, but also at the neural level. And to illustrate the constraints of the visual system, take a look at this famous grid illusion consists of intersecting gray lines where the dots seem to appear and disappear as you gaze through the image. To be perfectly clear, there really are 12 black dots in this image, but most people can't see all 12 dots at the same time. This may create an existential crisis because it did for me, but this illustrates the constraints of the visual system and how our brain circumvents these limitations. In this illusion, the black dot in the center of your vision should always appear, but the black dots around your periphery seem to appear and disappear. And that is because we have a pretty bad periphery vision, illustrating that our visual acuity is not the same across our whole visual field of vision. I will come back to that illusion, but for now, place your hands side by side, just like this image, and focus on just one of them. You will probably see a clear details of lines, wrinkles, pores, hairs, and varying discoloration wherever the hand that you're looking at. But now try look at the other hand without moving your eyes. You'll find that you lose all that crisp details and look blurry. You only have a clear fulvic vision at the width of your hand or the width of your palm, and as a result, the brain has to make its best guess about what's most likely to be going on that fuzzy periphery and fill in the necessary mental image accordingly. So that means when you're staring at that black dot in the center of your visual field, your brain is filling in what's going on around it. And with this regular gray line pattern on a white background, the brain guesses that there should be more of the same gray intersecting lines, but fails to process the intervened black dots around your periphery. And those dots will appear and disappear as your eyes move around like a camera, with the fovea focusing on the black dots, but the peripheries failing to capture its critical detail. So the grid illusion shows the limitation of our visual processing. However, the big part of the reason why we don't notice any of this in our day-to-day life is that our brain is doing what we call filling in. Effectively, the brain takes into account what has happened before and after the missing period and infers what was probably there in between, like we just saw with the grid illusion. And it is this inference that we actually perceive. And in the same way, we infer the contents of the blind spot, the completed contours of the occluded objects, and the details and the color of the peripheral vision. And altogether, the picture we experience is more of a fabrication and prediction than the actual reality. And in some ways, this is an inversion of unconscious processing. And with perceptual completion, we're effectively aware of more than what we could possibly perceive in reality. And we use our memory and expectations to bulk out the low quality of original perception into a rich and detailed visual experience. So with those in mind, I would like to leave this with a heavy philosophical can opener. With everything you have learned in this final chapter, what does that tell us when it comes to our conscious perceptual experiences? Does our experience cause the brain to activate in a certain way? Or is our decision just an experience, a story that we tell ourselves what the brain is already doing? So with that rabbit hole, I will lower the curtain with this final video. But as always, don't hesitate to let me know if you have any questions.